So I got my hands on a couple IP phones, and my initial idea was to crack them open and see if I could get 9 front to run on them. So far, this has been more trouble than I want to deal with. One has U-boot access, but it is password protected. A second has VxWorks, which has limited functionality, and a third seems to have no UART pins available. If Plan9 won't go to the phone, then the phone will go to Plan9. So that means dealing with this the way I dealt with the smart light bulbs. The smart lights I did in a previous video, I was told, could be cut open and the firmware flashed, but again, that was more trouble than I wanted to deal with. It's, they're kind of sealed plastic things, and cutting them apart, trying to glue them back together didn't seem ideal. So instead, I wrote a kind of Plan9 driver to present the bulbs as files. In the case of the bulbs, they natively spoke in JSON strings. And lucky for me, 9front has a library to parse JSON strings. So what do voice over IP phones speak? Well, they speak SIP, or SIP. And what is SIP? That brings us to the datasheets of the internet, the request for comment, or commonly called RFCs. SIP, or Session Initiation Protocol, is mostly covered by RFC 3261. In it, it is explained that they borrowed from HTTP to create a standard way for VoIP phones to set up calls between each other. While the sound is sent with various encodings, the rest of the protocol is plain text, including carriage returns, to ensure that there's full backwards compatibility with typewriters. So, armed with the knowledge that SIP packets are plain text and usually sent via UDP to port 5060, I started writing some code to capture these packets. So I set up some space to capture the packet, along with some stuff I'll need to handle the listen function. And then I set up this part here, which basically handles setting up a place to listen on a particular port. For, in this case here, I'm UDP. The asterisk here means any incoming calls, and SIP is already set up in Plan9. It already knows that that's port 5060. So it'll basically just sit here and wait for a call to come in. When it does, it'll get a file descriptor for it. I'll use this little function, which is just sort of a standard part of the library, to pull out the various information on that call coming in, print out where it's coming from, read the actual data out of that file descriptor into my buffer, print it out to the screen, close, and exit. And now I can actually test running it here. So I have another computer set up. And when I run it, it'll sit there and wait. And then I got a phone here. I can tell it to make a call. And there the packet came in. So we can see here the raw output. So when you make a call, an invite packet gets sent out, and it'll have various information on where it's coming from. So I have my name and the phone there. That's the IP address for it. Here's the IP address of the sound system here. And the rest of this is for basic other information. So how many times this thing could be forwarded. A user agent, this is the phone that I'm using. Things it supports, things it'll do. So these are the various other sort of messages it'll send. And then there's a content type. So this is another thing that'll come up. There's another protocol called SDP. And there's 279 bytes of that appended to this. And that is this part here, which negotiates, so it'll tell the phone that you're calling what audio codecs it supports. So now that I can read the SIP packets, time to see if I can write them. So I can't just jump right into voice calls because that involves audio codecs, and my math skills are not good enough to deal with that. Thankfully, the powers that be wrote another RFC. RFC 3428 is an extension that adds text messaging, and my phone here can send text messages. Part of this is that the receiver is supposed to send back a reply to tell the sender that the message was received. So I read through that, and what was required is to send a 200 OK reply. So now I'll try that. So here's my little program for receiving a text message and sending a response. So packaged up a little malloc thing. And in main here. So again, I have some stuff set up for handling, some variables for handling the listen. Some stuff for sort of taking in the SIP packet. Some stuff for parsing it, because you have to be picky about what you send back. And then the same sort of code as before to wait for a call and accept it, and then get some information on it. So then run a couple mallocs for my input and output. This will be the read here. So I read from the file descriptor for the network, put it into my space here that I allocated. And then the first thing I'm going to do is basically grab the first word of the packet. For the request being sent out, the first word will be sort of the method that it's using. And in this case, I'm just going to grab the first 32 bytes. Stir talk here. What this will do is you give it a character, it'll look for those, and it will replace it with a null character, which basically means, like in my case here, I want to take the first space after the method name, turn it into a null character, and that means it's now at the end of the string. So I'll print that to screen, whatever I find. If it matches message here, I will run through this code. So what I'm going to do is I'm going to get pointers to the first line for all these various fields that I expect to be in the message packet. And these are ones I have to send back for it to be a properly formatted response. And then at the very end, so at the end of the message, if you noticed on the last one, so you can see 9 front here, Plan9 in general, actually makes carriage return a printable character, it's a little CR. Between the actual SIP part of the information here and the next thing, which is the content, which is at SDP, there will be just another new line and or carriage return and new line. So I check for that and know that anything after that is going to be my text. And rather than actually print all those, I then offset it by 4 to get past this set of carriage returns and new lines to the actual text of the text message being sent in. Then I go through and basically find all the carriage returns and make them null. So that means the pointers to all these various lines, the ends of them now all become null terminated. So they can just be read using the regular stuff and treated like just an independent string. Then I just go through and format it. So I start setting up SE print, which prints at the end of a thing. So I start off with my reply here. So this is when you do a response, it starts off with just notifying that this is SIP version 2.0. And that's different with the responses or the replies. The initial one coming in will have its method first. The replies will have this first. Then the code. And then the OK is kind of optional, but I put it in there. And then all lines have to be ended with a carriage return and new line. And then I just go through. One of the things I did find in there was when you get a response coming in or a message coming in, the from line at the end will have this tag, which is supposed to be a sort of random number that the sender generates. There's lots of things like that in here just to differentiate this as a specific call that's happening. So there's that. There's a call ID, which is also something that's generated. The sequence number always has to be the same between the replies, so it knows that you're replying to, you know, invite 180 or message whatever. On the response, oops, I probably should point out, so the 2 doesn't have that. On the response, you, the 2, who's getting it, needs to put your own. So I just go ahead and ran lrand to just stick a random number on the end of, so it'll have the same 2 line exactly as they're sending it to me, but I add the tag. And then I'm not sending anything back, so I'm putting in content length 0. So, and if that's right, I set this flag as worked. If it doesn't work, I flush everything out, free everything, and exit. So then I get the length of my string, whatever I ended up writing into the thing, and do a write back to that network field descriptor with the output of length. And then print out whatever the actual text message I received was. So let's go ahead and test that. So sip mess. All right, it's just gonna sit there and wait, and this will take a second to type this out on the phone because it's not exactly easy. This phone doesn't have like a USB port, so I can't plug in a keyboard. So I'm gonna send some gibberish through the T9 interface here. Let's see, select instant message, new. And this phone's also set up to do direct IP messaging, so I can just sort of put in an IP address, or if I set just one number, it knows that it's that on the subnet. So let's... So I'm going to send BEBE, and hitting send now. And there we got it. And the phone itself says that it was a success. So I was debugging this originally. If the message didn't get formatted right and sent back, the phone would sit there forever saying it was trying to send it. But now it just immediately gives a little response back saying that the message was successfully sent. All right, next is to try handling both text messages and a phone call. Now I can't actually answer the phone with 9 front. I don't have the audio codecs to talk to the phone. But what I can do is send a reply for testing that is reply 180, which is for ringing. And what that's supposed to do is if the other, if you are calling an actual phone, that phone itself will send back a reply saying that it's ringing, and the phone will actually on the other end be ringing. And a different one gets sent when the user actually picks up the handset and starts talking. So yeah, if this works, then the phone on my end will make the sound that a phone makes when the other end is ringing. And here is what it is. Same as before, pretty much. So I set up the connection here, allocate some space for my buffers, and read it in once I get it. Parsing out the method again, same as before. Go get pointers to the beginning of all the lines that begin with these particular words. Then make sure all the lines are null terminated. So the message works just like before. For a phone call coming in, that's called an invite. So that'll be the first word that comes in on the packet, all in caps. So this one has the same sort of thing as before. I had to add the tag. So in this case, I just set up a variable called tag and filled it using lrand. And then these are sort of optional. Just add them to see if my phone would pick it up and show it. And yeah, there's no no content to be sent back on this reply. So there's no extra words to put on the end, so content length of 0. One of the things I did different was on this worked flag, I set it to 2 for message and 1 for invite. So still, if it comes back as 0, it'll flush everything out, free everything, and close out. It then writes out the output that I generated back into the file descriptor for the network connection, closes all the connections there. And then if it was a 2, it'll print any text message that came in. So I'll keep the from line there, and then whatever ended up being that text. After that, finally free those and exit. So let's see what that looks like. So this one I called SIP try, and I'll run it. Go back over to the phone here. And there it is. So it's just going to keep making the ringing sound. I'll go ahead and tell it to hang up. But yep, here's the invite packet coming in. And it successfully answered it with the ringing response. So what about the future? Currently, I'm just using the direct IP calling feature on the phones I have. There are several other SIP features. One is a proxy. This is a thing you authenticate with, and then it goes and finds the person you are trying to call. Something like this could probably be tied into Plan9's existing authentication and password managing system. And it could use NDB to build a database of other SIP proxies to forward invite requests. On the other end is making a phone call. I'm sort of imagining this could be handled sort of like WebFS and other networking stuff. There could be a clone file. You read that to get a new directory. In the directory would be a control file to set up the connection, a status file to see the info on how the call is going, and then an audio file to read and write the audio data in and out of. Since all VoIP audio is encoded or compressed in some way, the audio would have to be piped into a decoder and then into dev audio. And audio going out would have to be encoded and then written into the VoIP audio file. And the audio is also, it's encapsulated in another protocol, it's RTP, I think. That includes some sort of quality of service information in that. So that's another part that'd have to be done. And since most of this is all plain text, just like the RC-based web server, HTTP-RC, this could also all be done in shell script. So if anyone wants to sharpen their RC scripting skills, it would be interesting to see it done. Something like a SIP-based messaging system would be pretty straightforward. But until then, have fun.